Welcome back to Math Solver 1117. Most of us, when we see a problem asking for the minimum and the maximum value for a function, we immediately differentiate, find dy by dx, and then put our derivative equals 0 and solve. But calculus is not always the fastest method. In fact, sometimes you can skip derivative entirely. Today I will show you 3 inequalities that can find minimum and maximum values much more quickly. And these are favorites in Olympiad and advanced problem solvings. Now the first one is triangle inequality. This is the most easiest way to solve any equation to find maximum and the minimum values. And this inequality is defined in a very simple and easy way, that is, if we have mod of x plus y, x and y are the integers, is less than or equal mod of x plus mod of y. Now I will describe through an example, then you will easily understand the concept how to use this inequality. So question is, if we have mod of x is less than or equal to 2 and the mod of y less than and equal 3, what is the maximum value for mod of x plus mod of y? So this is the question. We use here triangle inequality to solve this. So we have mod of x plus mod of y. This is the triangle inequality. Given bounds are mod of x is less than 2 and mod of y is less than 3. It means that mod of x plus y, that will be less than 2 plus 3 equals 5. So how we will reach this? We take x equals, because this is also equal, and y equals 3. It means that mod of x plus y equals 2 plus 3 mod, and this is equal mod of 5, that is 5. So maximum of mod of x plus y will be 5, and we get by x equal 2 and y equal 3. So here is a tip that triangle inequality is best for quick bonds. When you know bonds of part x and part y, you can easily solve this. Now I will discuss the next inequality. Now the next one is Cauchy-Schwarz inequality. First of all, I will define this and then how we will apply on functions. Cauchy-Schwarz inequality is also easiest as the triangle inequality. So we will describe this as a1 square, these are the integers, plus a2 square up to so on, this is finite, an square into Other is b1 square plus b2 square up to so on bn square. Then we will find that this is greater than or equal to, this is greater than and equal to product of both a1 b1 plus up to so on we have a and bn whole square. This is called the Cauchy-Schwarz inequality. Now I will describe this through an example because a and b are fixed real numbers. So here is the question, that is, if we have for any real numbers, x and y, situation is that x square plus y square equals 1. Find the maximum of ax plus by, where a and b are the fixed real numbers. You have to find the maximum value. So in the solution we will apply the Cauchy-Schwarz inequality. First of all, we will apply two vectors x, y and a, b. This will become, first one is, consider this is as a and this will be as b. So you get x square plus y square into a square plus b square, and condition is that this will be greater than or equal to product of both of them, ax plus by whole square. Now in the given situation we have x square plus y square equals 1. In the question this is given, so we will put this 1 a square plus b square greater than or equal ax plus by whole square. Now we will take the square root on both sides, and then we get mod of ax plus by, that will be less than or equal when we take square root on both sides, because this value can be positive or negative. So square root of a square plus b square. Therefore this will be the maximum value. So maximum value will be square root a square plus b square. Now the third one, most important inequality, is arithmetic mean and geometric mean inequality. Inequality, and you have to remember this is for non-negative, this will be only for the non-negative. So I will describe this as a1 plus a2 up to so on an, and divide this by n, total number of terms. This will be greater than and equal to square root of n a1, a2 up to so on an. This is the product. So we have find that condition is also given that with equality that if a1 equals a2 and up to so on, this is equal an. Now I will describe this through an example, then you will easily understand. So example is, let we have x is positive because this inequality holds for non-negative. X is greater than 0 and y is also greater than 0, and x plus y equals 10. You have to find the maximum of x, y, product of both of them. So for two positive numbers, we know that x plus y divided by 2 is greater than or equals xy square root. Now we will substitute the values here. X plus y equals 10. So 10 by 2, because in the question this is given, and this will be greater than or equal square root of xy. But we see that this implies 5 is greater than or equal xy, then we will take the square root on both sides. By taking the square root, we will get 25, that is greater than or equal xy. So equality condition will be if first term equals second term. It means that if x equals y, this is the equality condition in the question. So we will apply this here, and we have xy that is less than or equal 25. If we put both of them equal, it's mean that x plus y that was equal 10. So we get x plus x because x equal y. This is given equals 10, which implies that x equal 5. So similarly y is also equal 5 because both x and y are equal. So we get 5 into 5 equals 25. That is the product of x and y, which shows that we have to find in the question maximum value of product of x, y, that is equal 25, and condition is that when x equals 5 and y equals 5. If you found this video helpful, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. In the next video, we will solve another most important question for calculus and for further mathematics. Best of luck for your exam. Stay tuned.